This demonstration shows Shark's blending capability. Blending is the process of replacing sharp edges or vertices in a model with smoother, tangent continuous faces of transition. These changes may be needed to make a part more photorealistic, aesthetically pleasing, safer, stronger, or manufacturable. Shark supports one of the CAD industry's top blending tool sets. In fact, several years ago our software came out top in a blending and filleting comparison of 10 modelers by Joe Greco that included SolidWorks, Solid Edge, and others. Shark contains a variety of blending tools including simple constant radius blends as well as variable radius blends, hold line blends, fixed radius blends, vertex blends, elliptical cross-section blends, and face-face blends. This demonstration focuses on the simple constant radius blend tool. Our first example is from a part I created from specifications from Steve Wolf some years back. This was a part to test and compare blending functionality of solid modelers. In particular, blending around features. We have two extrusions in this boss, and blending to a degenerative radius. Let's turn it to the side, and you can see up over here any blends occurring on these three edges is going to create a challenging situation as it degenerates to this point. Alright, let's go ahead and first let's select our constant radius blend tool, and let's generate a blend between these two features. And let's generate a 0.2 inch blend, and let's select this edge, and you'll see it's going to grab all the tangent continuous edges associated with my selected edge. Likewise, now let's blend between these two extrusions in this boss, and we'll select this edge, and then we have one more blend coming up. And this is the interesting one, as we're going to blend around this edge, tracking around the boss, the extrusions, and back up to the degenerative point. So let's go ahead and select the edge, and let's see what kind of blend gets created. You can see it highlighted in red. Okay, let's move on to our next blending example. We'll go to Concept Explorer, and let's isolate this layer. And we have some geometry here where we have 6 edges all coming to a point. And in this example, we're going to demonstrate multi-radius blending to a shared vertex. Let's go ahead and select our radius tool, and this time we'll go ahead and create 0.5 inch blends, and let's select these 6 edges, 1, 2, 3, 4, 5, 6. And then what we're going to do is we're going to display our object info dialog box, which lists all the radius edges I selected and the radius values. And I'm going to go ahead and I'm going to change some of these radius values. Let's change this to 1/4 inch. Let's change this to 0.45. Let's change this to 7.5. And let's add in a setback too of 1 inch. And we'll hit apply, and you can see the interesting blends that get created here. Alright, next what we're going to do with this part, we're going to go ahead and confirm that the blends that we just did holds up to subsequent feature modeling commands. And we'll do that. We'll create a shell operation on it, and we'll create a shell at 0.1 inches. And what we'll do is we're going to pick this body, and let's have it open up the face on the back, the face on the bottom, and the face over here on this side. And then let's go ahead and look at the shell that was created, and we can see the blends all held through in a subsequent modeling operation. All right, our last blend demonstration shows Shark's ability to handle complex blend situations involving numerous faces and edges simultaneously. In this demonstration, you'll see the advantages of a robust solid modeler versus a NURB-only software modeler, a challenging task for Rhino users. First, let's go ahead and let's go ahead and blend a single edge. We'll blend this edge up on top at 1 inch. And let's select the edge. Let's go over to our blend tool, and now let's go ahead and select this edge. You can see we're smart enough to understand that we have a relationship between these two faces, and the capping blend is interfacing with the two bottom faces on top and the two faces on this side as well. Now let's go ahead and, instead of blending the edge, let's blend the face. And you can see how it handles that all the nearby faces. And then lastly, let's go ahead and let's blend the entire body at once. And this will grab all the edges and faces and smoothly blend them. Now let's go ahead and let's do a more complicated blend. And we're going to do this by creating some features in our part to create a complex edge situation. And we're going to go to the hold tool, and let's make a through hole normal to the face that's selected, and let's do a diameter of 2. And let's pick this face and this location to drill a hole through, and let's repeat for these additional faces. Let's rotate our part and let's get these 2 more faces. Okay. Now let's go ahead and let's shell this part. And we're going to shell it at 0.2 inches. And what we'll do is we'll pick the body, and this time there will be no open faces. So the entire part will be shelled out on the inside. And then let's go ahead and let's look at it by let's create a plane, and let's split the part into 2. And we'll pick our solid, pick our splitting plane, and then when it's finished, let's go ahead and just hide this piece, and let's rotate the part so that you can see the geometry that is created on the inside. So this is our situation that we're going to go ahead and blend. It's a very interesting case of edges and multiple faces coming together, creating a very complex blending situation. And first thing we'll do is we'll go ahead and select our blend tool, and this time we're going to go ahead and put a 0.2 inch blend, and we're going to blend the intersection of these tubes on the outside first. And I'll select this edge and that edge, blend them, and let's go ahead and do the bottom, edge 1, edge 2, and blend. So that's the outside blend. And now let's go ahead and let's blend the inside as well. And this is going to be interesting because we're going to blend these edges and these vertical edges at the same time. And let's go ahead and select these 4 edges, and now the vertical edges. 1, 2, 3, 4. And you can see the very complex blend that's created at the inside of these intersecting tubes. And now our final step is to blend the top face resulting from the pipe intersection. Now the shell operation was 0.2 inches. So what we're going to do is we're going to pick a radius of 0.1 inches. And this should create an interesting blend that should end up being a tube across the top. So let's just go ahead and select our face, release it, and you can see the very interesting blend that results. And that concludes our demonstration of simple constant radius blends with Shark.